Hello everyone, welcome to my channel Essentials of Electronics. In today's video, we are going to discuss about some basic concepts on active filters. Filters are generally classified into two types based on the type of components we are using. They are passive filters and active filters. Passive filters are those filters which use only resistors, inductors, and capacitors. For example, like this. Yes, active filters are those which use active elements like transistors, operational amplifiers, along with the resistors and capacitors. So, this is the basic difference between active filters and passive filters. We will discuss about the different types of active filters in this video. Active filters have advantages over passive filters. These active filters can build high quality filters without inductors, low output impedance, they are easily adjustable. They can provide high gain that is greater than 0 decibel. There are primarily four types of filters which are low pass filter, high pass filter, band pass filter, and notch filter. Notch filter are otherwise called as band reject filter. These are the four basic types of filter. We will understand the classification of these types of filters in this video. So these types are classified based on the output that is achieved from the filter. Low pass filter. The output when a particular signal of any range of frequency is passed into an operational amplifier coupled with resistors and capacitors, the frequency response that is obtained in this kind of low pass filter is only the lower signals are allowed and the higher frequency signals are blocked. So this is a practical frequency response and this one is an ideal frequency response. The second type is high pass filter. As the name suggests, high pass filter, the lower frequencies are not passed, only the higher frequencies are passed. So taking frequency on x-axis and the bandwidth on the y-axis, the filter doesn't allow lower signals of frequencies to pass through it. Only higher frequencies are allowed to pass through it, and the very higher frequencies, the bandwidth remains constant. This is an ideal curve, and this curve is a practical curve. Next, the third type of filter is band pass filter, in which a band of frequency is passed through. Yes, if we have a wide range of frequency, lower frequencies are not allowed, a particular band of frequency is allowed, and after that the frequency reduces. So this case is the ideal case and this case is the practical case. So when the maximum bandwidth is reduced to 3 decibel, the meeting points of the 3 decibel curve on the frequency response curve are met at the frequency point at two different levels of frequencies. One is upper cutoff frequency, the other one is the lower cutoff frequency. F1 is called the lower frequency cutoff and F2 is called as the upper frequency cutoff. The bandwidth is called upper frequency minus lower frequency, or it is mentioned like this. So the bandwidth is very important parameter in knowing the exact performance of the circuit. The next type of filter is band reject filter or notch filter. A particular band of frequency is rejected. All other frequencies are allowed. This is called band reject filter. Yes, this range of frequency is rejected. This range of frequency is allowed. This range of frequency is allowed by the band reject filter. So these are the 4 frequency responses of the types of filters. We will discuss about a simple first order low pass filter. First order low pass filter. I will draw the circuit of a first order low pass filter. The input signal is fed to a resistor. The other end of the resistor is fed to the inverting terminal. The non-inverting terminal is grounded to the inverting terminal. The important elements of the circuit are connected. V0. So R and C, the input voltage. When the input signal is fed in such a way, the lower order frequencies alone are allowed and the output is obtained. So this is the gain which is obtained, and around 10 power 4 the value reduces, 10 square. And the phase plot, phase in degrees, frequency on the x-axis 0. It reduces and then the phase is very much lesser as the frequency goes on increasing. So this is the circuit diagram of a first order low pass filter. If it is of second order low pass filter, another set of such a circuit is coupled together. Another example of first order high pass filter. The input signal is fed into the op amp through a resistor, and here the resistor and capacitor are in series to the input, which is fed to the inverting terminal of the op amp. The other terminal is grounded. This is a circuit diagram of a high pass filter. The resistor and capacitor are in series with it, so the frequencies of lower signals are blocked and higher frequencies are allowed. Hence, the gain which is obtained is lesser and only the bandwidth increases at higher frequencies. This is the bandwidth. If a plot is drawn between phase angle and frequency, at higher frequencies it is obtained and it lowers in this manner. These are the basics on the types of active filters and the circuit diagram relevant to first order high pass filter and first order low pass filter have been discussed in this video. Thank you.